Have you ever just looked at an object and thought, how in the world would I even begin to measure that? It's not a simple box, it's not a perfect sphere, it's just weird. Well, today we're going to pull back the curtain on that exact mystery. Let's get into it. Take a look at these two things, a big old tanker truck and a classic spinning top. At first glance, they seem pretty complicated, right? They don't really fit into those neat little shape categories we all learned back in school. These are what we call composite solids. Basically, objects made by smushing two or more simple shapes together. So, that leads us to the big question for today. How do you actually figure out the surface area or the volume of these kinds of everyday complex objects? I know it seems impossible, but I promise you there's a surprisingly simple secret to it. And that secret is, you just break it down. That's it. Any complex object, I don't care how intimidating it looks, is really just a bunch of basic shapes you already know. We're talking cylinders, cones, spheres. The real trick, the real skill, is learning how to see those simple building blocks hidden inside. This gives us a foolproof four-step plan that works every single time. Step 1, identify the object. Obvious enough. 2, and this is the most important part, you mentally break it apart into its basic shapes. 3, you do the math for each of those simple parts. And finally, step 4, you put it all back together the right way. And trust me, that last step is where it gets interesting. Let's go back to our tanker truck for a second. Can you see it now? It's not one super complex shape. It's just a simple cylinder in the middle with two half spheres or hemispheres stuck on the ends like caps. As soon as you see it like that, the whole problem just clicks. It becomes so much easier to solve. Okay, so let's put this method to the test. Our first investigation, surface area. We're talking about measuring everything on the outside of an object. But I've got to warn you, there is a trick to this that trips up a lot of people. Now, your first instinct might be to just calculate the area of each piece and add them all up. But as our source material warns us, that's a classic mistake. Why? Well, think about it. When you glue two shapes together, the parts that are touching get hidden, right? They're not on the outside anymore, so they can't be part of the surface area. To see this in action, let's work through an example. We've got this decorative block. It's a simple 5-centimeter cube, and sitting right on top is a hemisphere with a diameter of 4.2 centimeters. Our mission is to find the total surface area of this thing. So where do we start? Well, the most obvious place is the total surface area of the cube. All 6 of its faces. But of course, we're not done because we stuck that hemisphere on top. And here comes that trick I was telling you about. We have to subtract the area on the cube that's now covered up by the hemisphere. That little circular spot where they meet, it's gone. It's no longer on the outer surface, so it doesn't count. We have to take it away. And to finish it off, we need to add the new surface we just introduced. That's the curved dome of the hemisphere. So the logic is pretty simple. Start with the whole cube, subtract the part you covered up, and then add the new dome you stuck on top. So when you follow that logic, total cube area minus the hidden circle plus the new curved dome, you get your final answer, 163.86 square centimeters. See, even a tricky surface area problem isn't so bad when you just break it down into what's hidden and what's new. All right, let's move on to our second investigation, volume. This is all about how much space is on the inside of an object. And I've got good news for you. After the headache of surface area, volume is usually way more straightforward. And here is the key difference. With surface area, we had to worry about all those hidden and exposed parts. With volume, you can forget all that. The total volume is simply the volumes of the parts added together. And if a shape is being hollowed out or removed, you just subtract its volume. No tricks, no hidden surfaces to worry about. It's just simple addition or subtraction. Check out this juice glass. It looks like a normal cylinder, but look closer at the bottom. See that raised bump? That's a hemisphere, and it's secretly reducing how much juice you can actually fit in there. Let's figure out exactly how much we're losing. Okay, first, let's calculate what we'll call the apparent capacity. If we pretend that bump isn't there and the glass is a perfect cylinder, its total volume would be 196.25 cubic centimeters. This is the volume you think you're getting, just by looking at the glass. But we have to account for that sneaky hemispherical bump. The volume of that raised part, the space your juice can't go, is 32.71 cubic centimeters. You can think of this as the volume that the company is quietly taking back from you. So the calculation is just simple subtraction. We take the apparent capacity of the cylinder, and we subtract the volume of that bump, and boom,
The actual capacity of the glass is only 163.54 cubic centimeters. It's a perfect, real-world example of how this all works.
Okay, it is time for the final challenge, the big boss battle. This next problem is going to combine everything we've just learned about surface area. It's got multiple parts and a little twist to it. This is where we really put our new skills to the test.
So here's the object, a toy rocket. It's made from a cone that's sitting on top of a cylinder. Our job is to figure out the area we need to paint. The cone on top is going to be orange, and the cylinder on the bottom is going to be yellow.
Now here are all the details. And pay attention, because there's a catch. The cone has a 5-centimeter diameter, but the cylinder's diameter is only 3 centimeters. What does that mean? It means there's going to be an exposed ring at the base of the cone that's not covered up, and that also needs to be painted orange. Let's see how the numbers shake out.
Okay, for the orange part, the total area to paint is 63.585 square centimeters. Now remember, this number includes the curved surface of the cone, plus that little ring-shaped area at the bottom that wasn't covered by the smaller cylinder. And for the yellow part, the area we need to paint is 195.465 square centimeters. That's the curved outside of the cylinder, plus the circular base at the very bottom. And just like that, we've broken down and solved our final challenge. So you see, the secret was never about memorizing dozens of complicated formulas. It was always about learning to see the simple shapes hidden inside the complex ones. The only thing you have to remember is break it down. So the next time you see a building, a car, or even a coffee mug, ask yourself, what is this thing really made of?